Imagine pressing a rewind button on Earth. Not just a few years back, but 4.6 billion years into the past. Our planet's story is written not in books, but in rocks, fossils, mountains, and oceans. This is the geological history of Earth, a dramatic journey of fire, ice, collisions, extinctions, and rebirth. To understand this vast timeline, scientists divide Earth's history into eons, eras, periods, and epochs, like chapters in an epic book. Paleozoic era, 541 to 252 million years ago. Life takes over the land. The Paleozoic era marks a decisive chapter in Earth's history, spanning from 541 to 252 million years ago. It represents the time when life, which had long been confined mainly to the oceans, began to diversify rapidly and spread onto land. This era witnessed the foundation of modern ecosystems, setting the stage for future life on Earth. Beginning of the Paleozoic, the Cambrian explosion. The Paleozoic era began with the Cambrian period, marked by a sudden and remarkable increase in the diversity of life, known as the Cambrian explosion. During this time, most major animal groups appeared in the oceans. Organisms developed hard shells and skeletons. Marine life became complex and abundant. This rapid diversification is well recorded in the fossil record. Life in the oceans. Throughout the early Paleozoic, oceans were dominated by trilobites, brachiopods, corals, mollusks, early fishes. The appearance of jawed fishes during the Silurian and Devonian periods earned the Devonian the title Age of Fishes. Colonization of land. One of the most significant developments of the Paleozoic era was the movement of life from water to land. Plants were the first to colonize land during the Silurian period. Early land plants helped stabilize soils and alter the atmosphere. Insects followed, feeding on plants. Later, amphibians evolved from lobe-finned fishes, becoming the first vertebrates to live on land. Development of forests and coal formation. By the late Paleozoic, vast swampy forests covered large parts of the continents. These forests were dominated by giant ferns, horsetails, club mosses. Over millions of years, the remains of these plants were buried and transformed into coal deposits, which today serve as major sources of fossil fuel. Rise of reptiles. As climates became drier, reptiles evolved with key adaptations such as scaly skin reducing water loss. Amniotic eggs allow reproduction away from water. These adaptations allowed reptiles to thrive in diverse terrestrial environments, reducing dependence on aquatic habitats. Formation of the supercontinent Pangaea. During the late Paleozoic, continental plates gradually moved together to form the massive supercontinent Pangaea. The formation of Pangaea. Altered global climate patterns. Reduced shallow seas. Influenced the evolution and distribution of species. Mountain-building events also occurred as continents collided. The Permian extinction. A catastrophic end. The Paleozoic era ended with the Permian mass extinction, the most severe extinction event in Earth's history. Nearly 90% of marine species. About 70% of land species were wiped out, likely due to massive volcanic eruptions, climate change, and reduced oxygen levels. Significance of the Paleozoic era. By the end of the Paleozoic era, life had fully established itself on land. Complex ecosystems had formed. Major plant and animal groups had evolved. Although the era ended in catastrophe, it cleared the way for the rise of new life forms in the Mesozoic era. Mesozoic era, 252 to 66 million years ago. Age of reptiles. The Mesozoic era marks a major phase in Earth's geological history, extending from 252 to 66 million years ago. It is commonly known as the Age of Reptiles because reptiles, especially dinosaurs, dominated life on land, in the oceans, and in the air during this time. This era followed the devastating Permian mass extinction and witnessed the recovery, diversification, and dominance of new life forms. Beginning of the Mesozoic. Recovery after extinction. At the start of the Mesozoic era, Earth's ecosystems were severely damaged. However, life gradually recovered during the Triassic period. During this time, reptiles adapted to dry climates and expanded rapidly. The first dinosaurs appeared. Early mammals evolved, though they remained small and less dominant. The climate was generally warm and dry, favoring reptilian life. Breakup of the supercontinent Pangaea. One of the most important geological events of the Mesozoic era was the breakup of the supercontinent Pangaea. As tectonic plates moved apart, new oceans formed. Continents drifted toward their present positions. Coastlines expanded. This continental breakup created diverse environments and promoted biological diversification. Jurassic period. Age of dinosaurs. The Jurassic period marked the height of dinosaur dominance. Large, herbivorous dinosaurs roamed vast landscapes. Powerful carnivorous dinosaurs were top predators. Marine reptiles such as ichthyosaurs and plesiosaurs thrived. Flying reptiles called pterosaurs ruled the skies. The first true birds evolved during this period, linking dinosaurs and modern birds. Evolution of plants. Plant life also changed significantly during the Mesozoic era. Gymnosperms, such as conifers and cycads, dominated early. During the Cretaceous period, flowering plants, angiosperms, appeared. The spread of flowering plants transformed ecosystems and supported new insect species. Cretaceous period. Diversity and adaptation. The Cretaceous period saw continued diversification of dinosaurs, mammals, birds, and insects. Dinosaurs developed a wide range of sizes and forms. Mammals began evolving specialized traits. Coral reefs expanded in warm seas. Earth's climate remained warm, with high sea levels flooding continental interiors. End of the Mesozoic. The mass extinction. The Mesozoic era ended dramatically with the Cretaceous-Paleogene KPG mass extinction. A large asteroid impact, combined with massive volcanic eruptions, caused sudden climate change, global darkness and cooling, extinction of all non-avian dinosaurs. This event reshaped life on Earth. Cenozoic era, 66 million years ago to present. Age of mammals. The Cenozoic era is the most recent chapter in Earth's geological history. Beginning 66 million years ago, after the extinction of dinosaurs, this era marks the rise and dominance of mammals, along with the development of modern ecosystems. Because of this, the Cenozoic era is commonly known as the Age of Mammals. Beginning of the Cenozoic. Life after dinosaurs. The Cenozoic era began after the Cretaceous-Paleogene mass extinction, which eliminated most large reptiles, including non-avian dinosaurs. With these dominant animals gone, mammals rapidly diversified. Birds expanded into new ecological roles. Ecosystems began to reorganize. This period provided mammals with opportunities to grow in size, complexity, and diversity. Major divisions of the Cenozoic era. The Cenozoic era is divided into three main periods: Paleogene period, Neogene period, Quaternary period. Each period represents important evolutionary and environmental changes. Paleogene period. Mammals rise. During the Paleogene period, mammals evolved into many forms, including early horses, whales, bats, and primates. Birds became major predators and herbivores. Flowering plants continued to dominate landscapes. Earth's climate was generally warm at first, but gradually began to cool. Neogene period. Shaping the modern world. The Neogene period was marked by expansion of grasslands, evolution of grazing mammals such as horses and antelopes, further development of primates. Mountain-building events such as the formation of the Himalayas influenced global climate and monsoon patterns. Quaternary period. Humans and ice ages. The Quaternary period includes repeated ice ages, evolution of Homo sapiens. Large ice sheets covered parts of North America, Europe, and Asia. Humans adapted to changing climates, developed tools, agriculture, and civilizations. Climate changes during the Cenozoic. One of the defining features of the Cenozoic era is long-term global cooling. Key factors include changes in ocean circulation, mountain uplift, reduction of greenhouse gases. These changes led to polar ice caps and modern climate patterns. Modern flora and fauna. By the late Cenozoic, modern mammals and birds have evolved. Present-day plant species became widespread. Ecosystems similar to those today were established. Humans became a major geological force, influencing landscapes, climate, and biodiversity. Earth's story is still being written. Earth's geological history reminds us that change is constant. Continents move, climates shift, species evolve, and extinction is part of the cycle. We are not separate from this story. We are the latest chapter in a 4.6 billion-year-old journey, one that is still unfolding beneath our feet.